Hello, good morning, students. This is Sandra Devi, working as Assistant Professor in Department of Mechanical Engineering in MBA College of Engineering and Technology. In this session, we are discussing about LOM, the Laser Operating Manufacturing System. In the last class, we have discussed about the definition of the LOM and also how it works on the different process manufacturing systems. Okay, uh, laminated object manufacturing. Solid physical model made by stacking layers of sheet stock, each on in each an outline of the cross-section shape of a cat model that is sliced into layers. Starting sheet stock includes paper, plastic, cellulose, metals, or fiber-reinforced materials. The sheet is usually supplied with adhesive backing or rolls that are screwed between two reels. After cutting, excess materials in the layer remains in place to support the part during building. Laminated object manufacturing. Why it is used? Laminated object manufacturing is also one of the type of the solid-based rapid prototyping system. In this solid-based rapid prototyping system, how it injects, how it develops, with depends upon the laser beam systems, how it develops the product throughout the area of the sections. In this laminated object manufacturing, the solid type of a physical sheet layers of sheet stock, outline of cross section shape. I mean, so the CAD model will be sliced into the layers. Sliced into layers. After it sliced into layers, it includes a paper, cellulose, plastic, metals, or reinforced materials. Different types of materials it can be used. The sheet is usually supplied with adhesive backing rolls that is spooled between the rails. Rails means what? The two sides of the reels will be fixed. By this reels only the product will be goes on continuing, and also the supporting part of the reels will be in the laminated object manufacturing process. These are the advantages which are used in the laminated: ability to produce larger scaled models, uses very inexpensive paper, fast and accurate, good handling strength, environmentally friendly, not health threatening. These are the advantages of the laminated object manufacturing. Disadvantages: need for decubing, which requires a lot of labor, can be a fire hazard, finish accuracy and stability of paper objects not as good as materials used with other prototyping methods. And in this laminated object manufacturing system, typical uses will be used: investment casting patterns, concept verification, masters for silicon rubber injection tools, fit check, direct user. Typical uses means when the when a laminated object manufacturing is a layout started automatically, where the product is given in that object, it will have an typical measurements or typical methods which are used in this as a manufacturing systems. Okay, these are the steps which are used for the typical manufacturing systems. Next one, extrusion based additive manufacturing. Extrusion based additive manufacturing is nothing but these technologies can be visualized as similar to take icing in that material contained in a reservoir is forced out through a nozzle when pressure is applied. The material that is being extruded must be in a semi-solid state when it comes out of the nozzle. The material must fully solidify while remaining in that shape. See, these technologies can be visualized. Means when we tag extrusion based additive manufacturing, means extrusion based systems, the technologies can be visualized as texture can be visualized. Means when the product is running inside the model, automatically we can see the front side from the system, how the product is going on, the procedure by step in that material contained in a reservoir is found through a nozzle when pressure is applied. The material is being extruded must be Semi-solid state to semi-solid state when it comes out of the nozzle. The material must fully solidify while remaining in that shape. Okay. These are the key features which are used in the laminated object manufacturing. These are the case means loading of material, liquefaction of the material, application of pressure to move the material through the nozzle extrusion, plotting according to a predefined path in a controlled manner, bonding of the material to itself or secondary build materials to form a coherent solid structure, inclusion of support structures to enable complex geometrical features. Means loading of material, key features means loading of material. Loading of material means if we are taking a CAD model, the CAD model is inserted into the object. Inserted into the object means any manufacturing system object. After that object, liquefaction of the material will be applied. After the application of the pressure, to move the material through nozzle extrusion. Extrusion will be applied. Next, plotting according to the predefined path in a controlled manner, bonding into the material or secondary build materials for coherent solid structures also be modified. Okay. Another key features we have taken is we would like to have material in semi-solid state, but handling cost and capabilities will be more. So we have to material in form of the pallets, that is a solid. The material inside the chamber should be kept in a molten state, and also the shape and size of the materials can be taken. Minimum size of the minimum feature size of size is based on the based on a diameter of a nozzle can also be taken. Next, extrusion part. Extrusion means mass flow is related to it. The pressure drop between chamber and also the surrounding atmosphere, nozzle geometry, and the material viscosity can be taken from the extrusion process of the material. And the solidification process. Solidification process means once the material is extruded, it should ideally remain the same shape and size. Gravity and surface tension, however, may cause the material to change the size and shape may vary according to cooling and drying effects. See, we are taking the cooling and drying effects. That means the material when the product is moving on, the material which we are taking can be easily heat produced. Heat produced. If you are heat produced means automatically the solidification. I am talking from a solidification process. Before programming, we are giving we have to do the solidification process to the product. And the cooling is also very likely to be a non-linear, then it is possible to the resulting part of which will be distorted. Okay, the positional controller. The positional control means extrusion based system use a platform that indices in the vertical direction to allow formation of individual layers. The extrusion head is typically carried on a plotting system that allows movement in the horizontal plane. Plotting must be coordinated with the extrusion rate to ensure smooth and consistent deposition. Next, since the requirement is to move a mechanical extrusion head in the horizontal plane, then the most appropriate mechanism to use would be standard planar floating system. For example, belt drives or lead screws. Belt drive is what if we are taking an open belt drive like that, the belt drive will be rotates continuously. Rotate continuously means the extrusion process of the material can be plotted in a different methods or different planes, and also the requirements of extrusion process in the horizontal to move appropriate mechanism to use a standard planar system. In that standard planar system only. The plotting system can be introduced, and also the vertical directions of the yellow formation of individual layers. The plotting system can be coordinated, or the extrusion rate can ensure within smooth consistent deposition method. After that smooth continuation development, the different types of mechanical extrusion methods identified. Can be identified. Next, bonding. Bonding is nothing but the heat-based system. There must be sufficient residual heat energy to activate the surface of the adjacent region, causing bonding. Gel-based systems must contain residual solvent or wetting agent in the extruded filament to ensure the new material will bond to the adjacent regions. If there is a sufficient energy, the regions may adhere, but there would be a distinct boundary between new and previously deposited material. This can repeat a fractured surface where the materials can easily separated. Turn may result in a poorly defined part. Too much energy may cause the previously deposited material to flow, which is turn may result in a poorly defined part. Means bonding. Bonding means what? The heat energy systems can activate easily through the surface of the layers. By using the gel-based systems, we can easily solve or we can easily extrude the part of the material which we will be an adjacent layers of the deposited methods. If there is a sufficient energy methods, the deposited material can easily modify throughout the system of the material, and it can flows which it can be easily to remove the part of the material from the inside of the laminated object manufacturing systems. And also we can support generation. Support generation means in support systems there are two general forms. One is similar material supports, secondary material supports. The most effective way to remove supports from the part is to fabricate them in a different material. From the different material only you can modify the easily method of the sections. And also the variation in material parts can also be exploited so that supports are easily distinguishable from part material either visually or mechanically or chemically. To this extrusion based equipment should have a second extruder. In this way, the second material can be prepared with the correct build parameters and extruded in parallel with the current layer of the build material. In support generation means so when we are giving the product, we can give the support from the back side or front side. From that support only the product will the product will be designed, and that it can be fabricated throughout the process of the material, which can be exploited due to the supports and also the distinguishable from part material or chemically. Due to this extrusion based system should have a second extruder. In this way the second material can prepared with the correct build parameters and extruded in parallel with the current layer of the build material. Next, plotting and path control. Plotting and path control means extrusion based machines take input from CAD systems using the generic STL file format. This file format enables easy extraction of the slice profile, giving the outline of each slice. Part accuracy is maintained by plotting the outline material first, which will then act as a constraining region for the fill material. Determine the fill pattern for the interior of the outlines is a much more difficult task to for the control software. And also the extrusion process can be based on the CAD systems which can be taken from the STL file, generic STL file format. This file format can easily extruded with the slice profile giving the outline of the each slide. Part accuracy is maintained by plotting the outline material, which will then act as a constraining region for the fill material. Determine the fill pattern from the interior of the outlines is much more but difficult takes from the control software. Okay, next one, control of extrusion. In this control of extrusion, the input pressure, temperature, nozzle diameter, and the material characteristics are to be applicable. Control of extrusion is nothing but when we are taking the product will be easily continued throughout the process of the material. Input pressure. This variable is changed regularly during a build as it is tightly coupled with each input control parameters, changing the input pressure resulting in a corresponding output flow rate change. Okay, it is the input pressure means we are giving the pressure to the system. Okay, temperature. Maintaining a constant temperature within the melt inside the chamber would be the ideal cell situations. Nozzle diameter. Nozzle diameter also this is a constant for a particular build, but many extrusion-based systems to follow the interchangeable nozzles can be offset throughout the positions. Okay, material characteristics. Material characteristics means this would include viscosity formation, which would help in understanding the material through the nozzle. And also, since viscous of flue creep are very difficult to predict the accurately starting and stopping of the difficult. These are the control of exclusion process, which we seen in the material purpose. Input pressure, temperature, nozzle diameter, and the material characteristics. Okay. These are the supporting systems, and also the main key features of the laminated object manufacturing system. Okay, na? This one we will take from the solid physical model by using the stacking layers of the different types of methods. And different types of methods also we will take it as a cellulose metals or a fiber raised systems. Okay, these are the LOM equipment and also the process in the manufacturing systems. Take up roll, block, layer counter, tile, moving optics head, mirror, laser, heated roll, sheet metal, platform, and also the supply all. And this is the output generated through the systems. And also the take up roll will be rotated as we discussed in the earlier take up roll systems. Roll system is directly it will take from the bottom of the system, and it will directly roll to the where the mirror is adjusted the roll to come to here. Then with the laser beam systems and then the mirror systems, the product will be designed. After the product will be designed, it will fold, it will have heated fold roller, it will roll and it will comes down of the sheet material to platform and also the supply. If any modifications can be simplified, we can take it from the platform of the material and also the supply roll of the different types of LYM methods. LYM equipments also have an different applicable systems, which applicable systems in the uh, materials. Okay, see if you see in this diagram, it is very clear. Take up roll, a material roll will be rolled, and it goes from the inside. And this is an heated roll. Heated roll here also we can take it as because of the minute particles of a product we can modify in the heated roll. Okay, in this heated roll only it goes it this side. This is the laser beam system or mirror systems, which is depending upon the laser. Here the projected area will be projected of the product. Here see, this is the area of the product, this is the projected area of the product, and slowly it takes the positions of the current layer of the method. Okay, the part layer outline and also the crosshatch can also be determined through the systems. Okay, these are the paper feed roller which we will take into the laminated object manufacturing systems. And see, if we take up the roll, this is the mirror system which we are taking, and here in the mirror system it will directly project it to the sealed chamber or also the smokestack between the different types of methods. Okay, laser and also wasted paper take up roll. Next, adhesive back laid down also on this machine can heated roll and passes over the adhesive bonds, and also the laser systems can also be directly detected into the system. The processing phase comprises several operations. The initial steps include generating an image from a CAD STL file of the part to be manufactured, sorting input data, and creating secondary data structures. These are fully automated by a LOM slice. The LOM system software which calculates and controls the slicing functions. Next, this laminated object manufacturing is relatively low because of the rapid prototyping technologies. When thin slices of material are successfully glued together to form a 3D shape. The process uses two rollers to control the supply of paper with heat-activated glue to a building platform. When a new paper is in position, is flattened and added to the previously created layers using a heat layer. Next, the shape of the layer is traced and cut by a blade or a laser. When the layer is completely built, platform descends and a new paper is applied. When the paper is in position, the platform moves back up so the new layer can glued to the existing stack and the process repeats. The LOM companies and applications can be applicable is the original technology which is used in the sources can be seen in this figure. Here we are taking one of the product which we are taken from the laminated object manufacturing systems. Okay, and this is the laminated the object of manufacturing. And next, advantages and disadvantages: ability to produce scale models, good handling strength, not health threatening. These are the advantages. And typical uses is investment casting patterns, concept verification, masters for silicon rubber injection fields, injection tools, quick check, direct use. These are the different the typical uses which are in the which are used in the system. Extrusion based additive manufacturing system can also have the visualized through the material in a reservoir out of the nozzle. When pressure is applied, the material that is being extruded must be in the semi-solid state when it comes out of the nozzle. Okay. Next, key features. We are taking the key features: the loading of the material, liquefaction of the material, application of pressure, plotting according to the defined path, inclusion of support structures are the key features of the materials. And also size and minimum feature size is also helped into the key features. Extrusion mass flow rate is related to pressure drop between chamber and surrounding atmosphere, nozzle geometry, material viscosity. These are the types of the extrusion process. And solidification: once the material is extruded, it should ideally remains the same shape and size. And also this can be minimized by using a controlled environment chamber. Next, position control. Position control can also be plotted in different methods by using the different applications of the extrusion process. Next, support generation. Supports in such systems can take it as a two general forms. So one is similar material system, secondary material systems. And this variation can also be easily identified in the support generation systems. Okay, plotting and path control. Plotting and path control is nothing but the path accuracy is maintained by plotting the different methods. Determine the fill pattern for the interior outlines, and the control software is a plotting of the path control. Control of extrusion can also be determined throughout the process of the material. And in this process, we have discussed about the input pressure, temperature, nozzle diameter, and also material characteristics. This is the unit 2. In this unit 2, we are discussing about the solid based rapid prototyping systems. Solid based rapid prototyping system is laminated object manufacturing types of solid based uh, laminated object manufacturing and fused manufacturing systems. So these two. In these two only, we are discussing the different types of extrusion process and also different types of procedures which we are taken from the materials and also we discussed about the support generation of the materials and the plotting of the path control and different methods of bonding and solidification purposes can be taken as a in this laminated object manufacturing. This laminated object manufacturing can also be used in different technologies in nowadays. Nowadays, like bottles and also like screwdrivers and also like wrenches. We can easily modify it by using the this laminated object manufacturing systems. Means it will by using the lighter laser beam system only, but here the simply modification we have to keep the rolls. If we keep on rolling, the stresses will be reduced. Means some of the stresses will be reduced in that product. After that reduced product only, the object which we are giving to the outside, the product finishing methods will be fabricated through the process of the materials, and then it will be an easily identifiable through the systems. Okay, these are the systems which are used in the laminated object manufacturing systems. Thank you, students. We will meet in the next class.